Two of us will be presenting today. I'm Floyd Smith, Director of Content Marketing at NGINX, and with me is Faisal Memon, Product Marketer for NGINX. We have pretty strong tech backgrounds from Apple and Alta Vista. In my case, I've written some tech books, and Faisal has been at Riverbed and Cisco before joining us at NGINX. Today, we'll be talking about introducing NGINX. We'll cover the history of load balancing, some basics and essential elements, how to improve performance, how to take it from HTTP to TCP UDP load balancing, and DNS service discovery. And first, introducing NGINX. We won't talk too much about NGINX and NGINX Plus today, except in context with load balancing. But 53% of the top 100,000 most visited websites use NGINX, either reverse proxy as an application server or both. And that number's been climbing steadily, certainly the entire time that I've been with the company, which is coming up on a few years now. And why would people at these busy websites convert over to using NGINX? Well, NGINX Plus can be used in a few different ways. And I'm going to go right to left here. So the N on the 4 servers shows NGINX running as an application server on 4 different servers that are being load balanced. NGINX was originally created to be a very high performance, very resource efficient web server. And as such, it was able to handle larger and larger loads without falling over, as some other web servers tend to. Basically, NGINX keeps its memory footprint flat and handles each connection as a separate event. So it then just keeps an event queue. So it doesn't take more resources as the number of connections increase. But the use case that we really see a lot of for NGINX and NGINX Plus today is as a reverse proxy server, which then, once put in that position, handling the traffic, has a lot of benefits. Let me speak first about just the reverse proxy benefits. You're offloading your internet traffic handling from the application servers to a separate server. You can secure the different servers appropriate to their roles. Because communications over a local network are so fast, the users out in the cloud don't see, the users out there don't see anything, any delay from the extra level of indirection. But you get all of this capability, including the ability to add caching to the reverse proxy server, offloading the application servers, to do load balancing among the application servers, to terminate SSL, and a number of other capabilities. Again, security can be cranked up for the reverse proxy server and then set appropriately for the local area network for the application servers. You still have to guard, but it's just a different set of challenges and not as pressing. And NGINX as a load balancer. We have a survey that says that large companies are very interested in global load balancing and smaller ones in CDNs and the public cloud, so NGINX is widely used by CDNs. Load balancing is a hot topic on our website. You'll get these slides afterward, by the way. We'll be sending you the slides and you'll be able to follow all of these links. There's a Gartner report that shows NGINX as an ADC and load balancing leader. There's an ebook, 5 Reasons to Switch to Load Balancing. 5 reasons to switch to software load balancing, sorry. And load balancing training, we have courses, we have professional services. It's a great group to take your architecture design to and review it with them and look for any holes or problems. And then our sales team is very collaborative, so they won't just give you a hard sell, but actually put you in touch with resources that'll help you make a good decision. Now a brief history of load balancing, and I'll cover this and then hand over to Faisal for the technical depth. These are hardware load balancers. And there's a commonly used saying now that software is eating the world, from Mark Andreessen. So what happens in many cases is that a particular problem, like load balancing, is first handled by hardware. So we saw F5 and Citrix come along and offer hardware load balancers. But then we saw almost at the same time, just a few years later, NGINX started being used for a software load balancer and running on industry standard hardware. At one point, the load balancers were able to actually help with price performance. So you would drop one of these boxes in front of your application server or servers, And before load balancers, when you wanted more performance, you just had to get a bigger and bigger server. And at a certain point, first of all, that's expensive, because when you go to the high end for performance, it's expensive. And second, it doesn't scale past a certain point. You can only get one box to do so much, no matter how much money you spend on it. Well, with a hardware load balancer, you could drop this in front and then share the load among a number of modestly configured servers. There's a term of art in the storage area, redundant array of inexpensive disks, or RAID. Well, you just got a redundant array of inexpensive servers, and you could scale out rather than scaling one server up. That gave you a lot better price performance. The trouble is, for F5, Citrix, and others that make hardware load balancer, is that that same logic eventually applied not just to the servers, but to the load balancers as well. So today, you can do a price performance comparison between an F5 Big IP and NGINX Plus. It's easy for me to say you can do one. Faisal actually did this work, which was pretty exacting. And let's just take a look at the total cost for 1 year. F5 Big IP, when you include the expensive hardware, running custom software on it, and support, $20K a year. Same thing with NGINX Plus, $4,700. So almost an 80% savings. And that just gives you so much more flexibility. It's a lot easier to make $5,000 decisions than it is to make $20,000 decisions. Let's look at the metrics too, just to highlight how strong the NGINX offering is. At the same price, same request per second. The SSL TLS transactions per second, much higher for NGINX Plus. And the throughput is much higher. It's very common that someone's running an F5 or similar. They break through an artificial throughput limit, and then suddenly they're paying much more in fees than they previously were, and that's just an unbudgeted for unexpected cost. You don't have that kind of thing with the software alternative. And NGINX Plus works in all environments, taking the flexibility theme further. The price difference is easy to put in a table, but really in a DevOps and continuous integration world, you need flexibility. NGINX Plus is extremely flexible. You can set it up and then move it across different environments. So now I will turn over to Faisal, who will take you into the depths of load balancing.
Thanks, Floyd. Thanks for that great overview. And before jumping into some of the NGINX specifics of how to configure load balancing, I wanted to just do a little level set here. And load balancing is, as Floyd said, quite simply just having a redundant array of servers, inexpensive servers, and you have something in front of those servers, a load balancer that distributes the load and the traffic evenly amongst the servers. And there's a number of different benefits to doing things this way. One is availability, that if you have more than one server running your application, if one of those servers fails, you're still okay, you can still deliver your application. The other is performance, that you can only scale a single server so much, at which point you hit the limit there and you do need to scale out. So having load balancing also enables you to get better performance. In the world of load balancing, there's a lot of different concepts, but I always hold on to two of them that I have labeled on the side. One is the pool, and that is the set of servers that you're load balancing to. There's multiple different names for it. Pool is one of the more common ones. In the NGINX world, we call them upstreams. Some people call them back-end servers as well. So throughout this presentation, you might hear me kind of interchanging them, but they all kind of mean the same thing. It's that set of servers behind the load balancer. And then there's the concept of the virtual server, and that is the front end of the load balancer, and that is the side that the clients connect to. That's where the public IP address is hosted, the port, and is the front end of the load balancer. So virtual server and pool. So you'll hear those terms come up quite often through this presentation. So how do you configure load balancing in NGINX? And there's a few key directives that we'll look at. And if you're coming from the F5 world, this might be a little difficult to see, because you might be used to using a UI to do configuration with NGINX, all configuration is handled through text files, through configuration files, which is kind of the standard for Linux and Linux-based software. But nonetheless, it's not super difficult to get up to speed with NGINX. And throughout this presentation, I think you'll see that it's actually pretty simple to configure basic things like load balancing. And so the first directive in here is called the upstream directive, and that is where you define the pool. And as I mentioned in the previous slide, we call them upstreams in NGINX, and that's just because that's what the configuration directive is named, is upstream. So you define the upstream, you give it a name, and in this case, I just selected a simple name, my_upstream. Then within the curly brackets, you list one by one each server in your pool, prepended by the server configuration directive. And it can be either the IP or the host name of the server. It's entirely up to you what to use. So in this case, we have two servers that we've listed. The next thing is the server directive, and that is what defines the virtual server in the NGINX world. And within the server directive, we have a bunch of other directives that do the logistics of what a virtual server does. The first one is the listen directive, and that is where you specify the IP address and port that the virtual server is listening on. By default, NGINX will bind to all IPs on the system, and this is something that is different than the F5 and Citrix way of doing things, where you have to manually assign an IP address to each virtual server. With NGINX, the network configuration, or at least the IP configuration, is split out, so that's handled by the system, and then NGINX in turn will then just bind to IPs that the system is listening to. So by default, it binds to all IPs in the system, and if you don't specify an IP address, that's what happens, as I've done in this case. You can also have it restricted to a single IP in the system by defining the IP address here. By default, it also binds to port 80 for HTTP traffic. I've listed port 80 here just for clarity and just so I can have this directive here. By default, it does listen to port 80. You can, of course, specify whatever port you want in this directive. The next directive is the proxy pass directive, and that is what links the virtual server to the pool. So we define this pool, we call it myupstream, and we define the proxy pass directive with the HTTP:// in front of it, so that now NGINX, when it sees traffic on location / or the root directive or the root of the site, and any subdirectories or anything underneath it, will be redirected to that pool. The last directive is proxy set header, and this is necessary because NGINX by default will rewrite the host header to the name of the name of the proxied server or the name of the group of the proxied server. So in this case, it would rewrite the host header to my_upstream. In most cases, this is not what you want, and so we typically reset the host header to the original money host. That's the NGINX variable that holds the original host header coming in from the client. So we're just basically pushing that original host header forward with this configuration directive. And so that's the basics of load balancing configuration with NGINX. I did touch a little bit on the location block here, and we'll come back to that in a little bit. So some key files and directories. So we have this configuration, where is it stored? So there's the etc NGINX directory, and that's where all NGINX configuration is stored. And there's the main top-level NGINX configuration, and that's nginx.conf in the etc NGINX directory. And that file should not require a whole lot of modification. And there is some modification that you can do to it, and we'll get back to that later on in this presentation. But for the most part, you don't need to touch this file. Where you put your actual configuration for your virtual servers and your upstreams is in the confd folder with a file with the .conf extension. And I typically just do it this way, as I've done in the example here, just the URL of the site, .conf. So www.example.conf is where you would put your virtual server and upstream configuration. Okay, so moving forward, so that's the basics. With that configuration, you have a fully functional load balancing configuration. And we're going to step through a little bit of the essential elements. It's not always enough just to do load balancing. You need health checks, you need session persistence. You might want to terminate SL traffic. So there's a couple other things we can do there. We're going to step through that now. So one question that's come up a few times recently is, can you multiplex multiple sites on a single IP address using NGINX? The answer is yes. And the way we do that is by stacking virtual servers. So you have multiple virtual servers, and they all have the same listen directive, and so they're all listening on the same IP address and port. And the way we multiplex that is with a server name directive. And each virtual server has a different server name. And in this case, we just use example.com, example2.com. So now if the NGINX receives a request on an IP address and port, it's going to look at the host header that it receives. And based on the host header, it'll look for the matching virtual server with the matching server name directive and use that to process traffic. The other directive or parameter more specifically here is default server, and that is needed so that NGINX knows what to do with traffic that doesn't have a host header, for example. What does it send that traffic to? It needs a default, and so you define the default using default server. So that's how you multiplex multiple sites on a single IP address using NGINX. So I touched on the location blocks a little bit earlier because you need a location blocks to do the proxy path, to link the virtual server to the pool. And I want to revisit that topic on this slide because I think location blocks is one of the most powerful directives within NGINX. It's something that is commonly used and something pointed to by our users as one of their favorite features of NGINX. And what you can use location blocks to do is to do layer 7 routing based on URL. So you can perform different actions based on the URL. And in this simple example here, based on what comes in after, or what the root of the URI is, whether it's service 1 or /service2 or /service3. If the user is coming in as /service3, I'm going to select a different upstream group than if they're selecting if they're coming in from service 2. So you can use this location block to do that layer 7 request routing and take different actions based on the URI that the user has provided. So a very powerful directive within NGINX. One of the standard features of load balancing is active health checks. And so the open source NGINX has passive health checks. And what that means is that on actual user traffic, NGINX will send that to one of the servers that it's load balancing to. And if that server fails for some reason or times out or returns an error, then it will detect that and retry that request on a different server. That is called passive health checks. With the active health checks, what NGINX will do is that out of band, it will pull a certain endpoint that you specify every so often and check the response and make sure that it's okay. So it's called, a lot of people will call it out-of-band health checks or active health checks. So it's not operating on actual user traffic, it's generating synthetic or traffic specific to the health check. And so there's a few additional configuration directives on how to configure active health checks. So the first thing that you would do is that you would specify a special location for it. And in this case, we've just called it /health. We specify it as internal because we don't want clients accessing /health. That's just it's just our way to organize it. And the main directive is the health check directive, which I put in bold here. And that specifies the parameters for the health checking. In this particular example, I've set to health check every 5 seconds. And the endpoint on the actual upstream server that we want to check is test.php. So every 5 seconds, NGINX will now initiate a request to test.php. And this requires a little bit of work on the application side because you actually have to write the test.php script. And you can have it do a number of different things. You can have it just give a thumbs up. It can be very simple, or you can have it look through various system parameters, check the amount of available memory on the system, available disk, just do some checking on the system, and then return the thumbs up if everything's okay. The URI doesn't have to be a PHP script. You can just have URI equals / and NGINX will just do a request to the root, and we'll do the processing based on that. The next is the match block. So we're saying what we want to do is once we get the reply back from the server, we're going to go to this match block, and that's going to do what needs to be done, the processing that needs to be done to make sure that the request is okay or it's not okay. So moving down to the match block, so we see here that there's a status there. So we're saying that if the response is not 200, the server is marked as failed. So we want to check for 200. You can also configure this so a lot of people have it be more than just 200. A 300 might be okay. So that is configurable. In this case, we made it very restrictive and very strict that it has to be a 200. The next thing is the body directive here, and so we're basically applying a regex to the body of the response. That's indicated by the tilde. In the NGINX configuration world, tilde usually means regex. And the regex syntax is just standard PCRE regex. So if you're familiar with that, you're familiar with the syntax here, where we're just basically looking for servers alive with some sort of number after the server, a 0 to 9 number. And if we receive that response to the client, then NGINX says that the server is okay, and if it receives anything else other than that particular message in the response body, the server will be marked down. And the last directive that I want to point here that's somewhat related to active health checks is the slow start directive, and it's up at the very top. And what that means is that new servers that are introduced, or recovered servers that have recovered that have failed a health check, but later passed the health check and are returned to rotation, before they are given a full load of traffic, 30 seconds has to go by. So for 30 seconds, they're slowly, incrementally given more traffic. And that's done so that they are not overwhelmed right away, and also that you want to kind of dip your foot in the pool before kind of jumping in, make sure that the server is actually okay before just putting it back in full rotation. Active health checks is exclusive to NGINX Plus. Another common thing amongst load balancing is the concept of session persistence, and there might be a lot of cases where you want to pin a client to a particular server on the back end. And one common example of that is the shopping cart example. If the state for a user who started up a shopping cart or a session or anything that requires some sort of server-side state, and if that server-side state is stored on the actual server itself, then you need session persistence. And NGINX supports a number of ways of doing session persistence. One is the hash method, which is described on this slide. And what we're doing here is we're setting the hash directive and using the NGINX variable binary remote adder, which holds a binary representation of the client's IP address, and using that to do session persistence. So now what happens is that clients coming in from the same IP address are pinned to the same server. You see here there's a consistent modifier at the end of it, and what that does is that ensures that, for example, if I add in a different server, if I add in a third server to this group, that now the distribution is not going to be changed, so that if a client was, for example, pinned to server 1, I add a third server there, that might change, without the consistency there, that would change the hash computation, so that now that user might be pinned to server 3 instead. So what the consistent there does is that if we add or remove servers, it will ensure that, as best as possible, that even if that happens on that event, the same client still gets pinned to the same server. So there's no redistribution, so to say. There's a number of different pitfalls with using hash-based session persistence, or IP-based session persistence, is what it's typically called. One is that there could be hundreds of users sharing an IP address, which is very common for an office use case or for a home use case because of NAT. So you'll have multiple users sharing one IP address behind NAT, so that could lead to some uneven distribution. The second is that you're tied to the IP address, so you're tied to the networking layer. So if the client changes that IP address, for example, if I close my laptop off at home and try to finish off my shopping transaction in the office, well, that session could be lost because I changed my IP address. So to resolve the problems with IP hash-based session persistence, what people typically do is what's called sticky cookie session persistence. There's a number of different ways to accomplish that, and we support 3 different ways of doing it within NGINX Plus. And the one I'm going to go here is one that I typically recommend, is the sticky cookie session persistence. And what happens here is that NGINX will insert a cookie to the response for a client. And then on the next subsequent request, the client will present that cookie, and when NGINX sees that cookie, it's going to use that to determine what server it sends it to. So it's called a sticky cookie session persistence. And that is configured in NGINX with the sticky cookie directive. And you give it a name, and you set a few different parameters for it. One is the expires parameter, which I think is important. It says how long the cookie is valid for. And if you don't set it, then there's some defaults that happen. The defaults at the end of the browser session. And there's the domain and path parameters there which specify, respectively what domain and path the cookie is valid for. So it's important to do that because, and more so for the path, because if you don't specify the path, then the cookie will be specific to each path. So if the user comes into /x and then later comes into /y, that'll be a separate cookie. And in a lot of cases, that's probably not what you want. So specifying the path says that this cookie is applied to everything under the root directory, so it'll be applied to everything on this site. So it's important to specify path when setting up sticky cookies with NGINX. So cookie-based session persistence is exclusive to NGINX Plus. That's not something we put into the open source. The IP hash based session persistence is part of the open source, but the cookie-based session persistence we do make exclusive to our NGINX Plus customers. One of the most common things NGINX is used for is SSL termination, or more generally what you use load balancers for is to terminate SSL, and then you do clear on the back end, clear text on the back end. That saves some work on the application servers from having to do SSL, and also centralizes your SSL certificates, so now they're just hosted on the front-end load balancer, not spread out across all your application servers. So there's a number of different benefits to doing SSL termination. And the way you typically configure that in NGINX is on this slide here. And the first thing I do is I make sure that all traffic is forced to SSL. That's optional, of course. You don't have to do that. But it's typically recommended to do that. One reason is for SEO. Google will give you a higher search ranking if your entire site is SSL encrypted. And two is that it makes your site more secure in that if it's in plain text, a man in the middle can tamper with your site. But if it's encrypted end-to-end, then it kind of puts the man in the middle out of the picture. And the third reason is spying. That man in the middle can also just passively spy, so he doesn't need to tamper with things, so he can just spy. So if you do encrypt your traffic, then it kind of takes that out of the picture too, so people can't spy on what your users are doing. So it's a good idea to SSL encrypt all traffic. So the way we accomplish that with NGINX is the return 301 here. And so I've defined two virtual servers, one listing on port 80, one listing on port 443. And on the virtual server listing on port 80, I'm doing a return 301. So I'm basically doing a 301 redirect for all traffic on port 80 to the HTTPS site, which is a virtual server below. And what's different here on the virtual server for SSL traffic is one, the SSL parameter on the listen directive, so that instructs NGINX that this is in fact an SSL encrypted virtual server. And second is that I have SSL certificate and SSL certificate key directives, which specify the public certificate and private key to use. And you just specify those just where they are located in your file system. So pretty simple, pretty straightforward, and that's how you configure SSL termination with NGINX. In a lot of cases, you might want to do SSL also to your backend servers. And so the way you accomplish that is quite simply on the proxy pass directive, just putting https : / instead of http : //. So if you do https, that'll instruct NGINX to do SSL to the upstream servers. So that's how you do upstream SSL with NGINX. So those are the essential elements on configuring load balancing. So we've gone through the basics of load balancing. We've gone through some of the more advanced stuff, health check session persistence. And I'm going to switch gears a little bit and talk about how you can tune performance a little bit and get a little bit better performance out of NGINX and your applications by configuring some NGINX parameters. And so first thing I do is go back to that main nginx.conf file. So I mentioned this earlier on in the presentation that there's this main conf file and you don't really need to change it much. But there are a few changes that you want to do, and this slide kind of encapsulates them. And the main one is really the worker processes directive there. And we want to set that to auto. And what that means is that now NGINX will have a separate worker process. And I'm not going to get too much into the NGINX internals, but there's a concept of worker process within NGINX, and that's what does the actual processing. There's also a master process that manages the worker processes. So by specifying auto, that means that we'll use one worker process per core, which is what we recommend for most deployments. And depending on where you've installed NGINX from, this could be set to 1, it could be set to 2, it could be set to auto by default, and that just depends on a number of different factors. So always make sure that that worker process is set to auto. The next thing is the keep live timeout and keep live request directives, and so that configures keep live connections on the virtual server side. And keep live timeout says how long to keep a connection open and let it be idle before closing it off. By default, that's 75 seconds. And for a lot of people, that's probably okay, but if you want to keep it open longer, for example, you have users that click around for a while before doing the next interaction, you might want to keep that connection open longer. And so that's configured with the keep live timeout directive. And the keep live request directive specifies how many maximum requests on a connection before it's closed. We set it to a pretty high number here, I think 100,000. That's probably too much for most use cases, but you know, if you're benchmarking, for example, it's nice to set that number to a higher value so you can see how much actual requests you can process without the TCP connection set up overhead. These directives don't have to be set at the main level. They can also be set at the virtual server level, or you can set them at the main level and then override them at the virtual server level as well. So you can have kind of a tree structure. So that's the virtual server side. You can also configure keep alive to upstream servers, and I recommend to do this. By default, NGINX will use HTTP 1.0 and connection close. So we'll just do one request per TCP connection, close off the TCP connection on the back end. It does this just for maximum compatibility, but in most cases, with most semi-modern, even semi-modern, stuff on the back end, you can use HTTP 1.1. And so the way to do that with NGINX is just the proxy HTTP version directive, and you just specify 1.1 there, and NGINX will then upgrade the connection to HTTP 1.1. And then you basically tell it not to send a connection close header, so you set the connection header using proxy set header directive and set that to blank so that there's no connection close header that's sent across. So that means that the connection will then be a keep alive connection. And the next thing you want to do is you want to specify a connection cache, and that's specified with the keep alive directive under the upstream block. And this is something you would experiment with to what works best for your use case, but 32 is just a number I picked, and in your use case you would pick whatever works better for you. And one of the questions that has come up is, does NGINX do multiplexing of connections or requests across TCP connections, or to bind one TCP connection to a user? NGINX does, in fact, multiplex requests across connections, across keep alive connections. And the F5 world, I believe, is called One Connect, and in the NetScaler world, there's another name for this. So in NGINX, it is just the default behavior. Elliptic curve cryptography is something that's come up a lot more recently. It's technology that has been around for some time, well over 10 years. So it's nothing new, but it has come up a lot recently for a number of different reasons. One is that it performs better than our typical RSA, and our testing 2 to 3x better performance because of the smaller key size that comes with elliptic curve cryptography. The other is that the RSA is starting to hit its limits in terms of you can only make the key so big before the performance, and it is diminishing returns on doubling the key size won't double your security necessarily. So there's a number of different reasons that elliptic curve has become much more talked about nowadays. So NGINX supports dual stack RSA ECC, and what that means is that you can configure NGINX to use both depending on what the client supports. And you just do that quite simply by just specifying both the RSA and ECDSA elliptic curve certificates within NGINX with separate SL certificate key configurations. And NGINX will just pick the one that's most suitable, so clients that do support elliptic curve will get the elliptic curve certificate. Clients that don't support it will get the RSA certificate. And most modern clients actually do support anything after Windows with Vista, or even Windows Vista itself, I believe, supports elliptic curve cryptography. OS 10.6 on the Mac side or later supports elliptic curve cryptography. So most clients out there do actually support elliptic curve cryptography. But it's always good to have backwards compatibility. Another way to improve performance is SSL session caching. And what that does is NGINX will store a lot of the parameters, the computations that were done to initiate an SSL session. And if you know SSL, the most expensive part of the SSL operation is the initial handshake and the key exchange, and setting up the shared key that's used for the block cipher later on. So you can have NGINX, cache those calculations to improve the performance of SSL setup and not have to redo that each time. So in this configuration, we have a 10 megabyte session cache, and each 1 megabyte can store about 4,000 sessions. We have 40,000 sessions we are caching, and we cache them for 10 minutes. The other thing to look at here is HTTP2. So we've enabled HTTP2 here, which also can improve performance. And the performance improvement does vary, but most people do see pretty nice performance improvement from HTTP2. And it's very simple to configure HTTP2 in NGINX. You just put the HTTP2 parameter on the listen directive along with SSL, and that'll give you HTTP2 support. One thing with HTTP2 is that it requires OpenSSL 102 to work properly. And there's a number of different reasons for that, but that's what it comes down to is you need OpenSSL 102. And so that means Debian 9 has OpenSSL 110, so it has even something greater than OpenSSL 102. Ubuntu 16.04 later has OpenSSL 102, so you need one of those two operating systems if you want to use HTTP2. Okay, so I'm just going to move. So everything we've discussed up to so far pretty much applied to HTTP load balancing. And over the past 2 years, we've added a lot of features around TCP, UDP load balancing to support those types of applications that don't just run over HTTP. And so I want to spend a little bit of time going over that. And most TCP configuration, if you look at it here, it looks very similar to the HTTP. The main difference is the stream directive up top. So all TCP, UDP load balancing configuration goes within the stream directive. One thing to pay attention to is that the port number is mandatory when specifying the server. So with the HTTP, you notice that I left the port number off, and NGINX by default assumes port 80. So you can make that assumption on the HTTP side. On the TCP side, we don't know the details of the application, so we can't assume the port number, so you do have to specify that. And the other thing to look at is the listen directive a little bit below on the virtual server side. You notice that I have the UDP optional parameter there, so if you don't specify that, it'll use TCP by default, and if you do specify UDP on the listen directive, NGINX will switch to using UDP for this virtual server. Otherwise, the configuration is pretty similar to HTTP, and if you're familiar with that syntax, you'll pick up the TCP UDP load balancing pretty quickly. One thing to note is that you can't put TCP UDP load balancing or just stream configuration into the conf.d folder. So what you need to do is you put a separate stream block in the main nginx.conf file, and then you put an include directive, and you create a separate folder called stream.conf.d or any folder. I just use stream.conf.d and include that, so just be include stream.conf.d, and then you put your virtual server and full configuration in there. So that's the best way, I think, to organize TCP UDP load balancing configuration with NGINX. And I'm just going to quickly step through some sample configurations. MySQL is a common application, TCP-based application. You can load balance that using NGINX. And the way you do that is by first setting up a Galera cluster. And I'm not going to go through the details of that because that's kind of beyond the scope here, but you can use NGINX then to do some reverse proxy for it. And in this example, we're not actually load balancing any traffic. And the reason for that is if you have multiple, you can't have multiple write masters with a Galera cluster. And if you do, there could be write collision. So what happens if two writes happen at the same time on the same entry, right? It's a difficult problem to solve, and it could lead to potentially erroneous data or just unexpected behavior if you do have multiple writes. And so what we're doing here is we're just having a backup. So we're sending everything, basically, reads and writes, to one server, and then the other two are backup, and the other one is down, so you have to manually put it into the rotation. But there's just one master and then one backup here. One thing to note is a proxy connect timeout directive. So a database calls, we want to timeout quickly. If the database is not responding, that means it might be overloaded. So then we time out very quickly and go to the backup. So the backup does come into play. It's just when the main one is heavily loaded. So that's something to pay attention to there. A slightly more complex way to do load balancing with MySQL is to split out reads and writes. And so what we can do now is we can have a single master for writes, and then we can load balance the rest of the reads across the servers in the cluster, which is probably more what you want if you're doing MySQL load balancing. And The downside of this approach is that it's a little more complex in that it requires your application code to be more database aware. So you have to split off reads and writes to different ports on the application side, and then if it gets, in this example, a read or request to port 3308, NGINX can assume it's a read and then load balance it across the read servers, and then if it gets a request to port 3309, it's assume it's a write and send everything to the single write master. But this is how you accomplish split reads writes with NGINX and MySQL, and it does require support on the application side. Something else that's a common application to load balance is DNS, and DNS is something that uses both UDP and TCP, and it uses TCP if the response is greater than 512 bytes. Otherwise, by default, it uses UDP. And a couple of things to note here in this configuration is that we have two listen directives because DNS does use both. We have the listen 53 with no modifier after it. By default, that's TCP with NGINX, and then we have the listen 53 with UDP after it. So now we're instructing NGINX on port 53 to listen to both TCP and UDP traffic. The other thing to note here is the proxy responses directive. With DNS, there's usually just a single request and a single response, right? That's how DNS works. And we need to tell NGINX that because NGINX doesn't know by default that it's load balancing DNS. So we tell it that that there's only one response here. Then by letting it know that, then once it gets that single response, then it immediately forwards it out. If it doesn't know that, then it has to wait for a timeout to happen, and then it'll send the request out, or should I send the responses out? So we have to specify with UDP how many responses NGINX should expect before forwarding the responses off to the client. And last thing I want to mention on this slide is the error log directive. And since NGINX doesn't know what's going on within TCP UDP streams, it can't have a standard access log like it does with HTTP. So by specifying an error log here, we at least have some information stored into a file about DNS traffic. So it gives you some visibility. And just as with HTTP, we have health checks, and this is exclusive to NGINX Plus. So you can do active health checks with TCP and UDP traffic, and it's configured very similar manner. If you have just health_check, NGINX will do a standard TCP connect health check, just create a new TCP connection, make sure that's okay, and then disconnect it. On the UDP side, it'll send NGINX health check to the server by default every 5 seconds, and if there's a destination unreachable, or expect the absence of destination unreachable. So if it does get destination unreachable, then it marks the server as down. So that's health checks with TCP, UDP, and NGINX Plus. Okay, moving on to the last portion of this before we move to Q&A, service discovery. And service discovery is something unique to a microservice use case, and it kind of comes up because in a monolithic application, everything's on the same server, and in microservices now we've moved application functionality and spread it across multiple servers. So now if service needs to interact with the service, it needs to first know where that service is, because it's not going to be on just the same server. It's going to be on a different server on a dynamically assigned port. And there's multiple different ways to accomplish it, and one method here is using console. And at the very high level, what happens here is that there's a container that monitors for other containers coming up or down. And once a container comes up, for example, it'll then register its IP address port into basically a database or a DNS database, so to say. And then NGINX will pull that database using DNS to get the location, IP address, and port of each service. And how you configure that in NGINX is with, and this is also exclusive to NGINX Plus, is on the server actual itself. So you specify the host name of the server, and with console, you specifically have to have, it's the name of the service .service.console. That's just the format that they follow. And you put two modifiers after it. One is service equals HTTP, and that tells NGINX that there's port information. By default, DNS doesn't include port information, right? It just assumes port 80. There's DNS SRV records, which is an extension to DNS, and that includes the port information. By using service HTTP, NGINX will look for the port information as well. And the second is a resolve directive, which tells NGINX to resolve this host name periodically, by default based on the DNS TTL. But if you see above, there's a resolver directive where we specify the name of the DNS server, and we have a valid modifier after that, which tells it that each DNS entry is only valid for 10 seconds. So we're overriding the default DNS TTL in this case. And that's optional. You don't have to do that. But it does give some sense of predictability if you do that. So that's how you configure it with console. Docker itself has an embedded DNS server, and the configuration is very similar. By default, the Docker embedded DNS server IP address is 127.0.0.11. That's just what they use. Otherwise, the configuration is pretty much the same as with console. There's no .service.console thing after it, so it's just the name of the service, which you specify in your Docker compose file. That's what you put up there as a service, the name of the service. And then we have the service equals HTTP and resolve, just as we do with console. Okay, and just to summarize what we talked about real quickly before we move on to the Q&A portion. And there's a couple main directives here. The server directive, what you use to define a virtual server within NGINX. And the upstream directive is how you define a pool. And the proxy pass directive is how you link the virtual server to the pool. Location blocks is one of the most powerful directives within NGINX, and that's how we do layer 7 request routing based on the URL. And if you want to support elliptic curve cryptography, NGINX can do that for you, and you just specify using the SO certificate key directives, both the RSA and the elliptic curve certificate within the same virtual server. NGINX also supports TCP and UP load balancing using the stream directives. And with NGINX Plus, you can integrate with the DNS interface of both Docker, console, and other service registries to do service discovery. Cool, and with that, that's it. I'm going to move forward to the Q&A portion.
So the first question that we see coming in is, can we do clustering on NGINX servers? So I'm going to give kind of an overview, and then Faisal will dive into the deeper part on most of the questions. Clustering is one of the favorite things that people do on NGINX servers, and actually in recent releases of NGINX Plus and NGINX open source, we've improved our clustering features.
And just to add on what Floyd said, we do clustering with NGINX Plus. We support high availability clustering, both active-active and active-passive, with using KeepleID, which is another open source project. And I'm not sure if the question is just, can we do active-active, active-passive? And we also, with NGINX Plus, we do configuration sharing as well. But we don't actually share state, so that's what's missing with NGINX. So we do the clustering, we do active-active, and we do share configuration, but we don't share state.
I will just add that there are some good articles about active-active and other configurations in the cloud and out of the cloud on the NGINX blog. Here's a question. Do you always recommend running the NGINX load balancer on physical machines versus virtual? That's a really good question. So actually, NGINX is used as a load balancer in the cloud all the time. It's a popular choice for high-performance websites on AWS, for instance. And we have detailed articles in our blog about different configurations for that, using it in combination with some of the services that AWS offers to get better performance and better manageability. You also get a kind of device independence. When you lean heavily on NGINX for your load balancing, you can then take that configuration and either move it to a different cloud or share it across clouds. We have customers who run on physical servers, for instance, and then when their physical servers all get busy, they just scale out into the cloud. And with this kind of configuration, you can scale out into the cloud of your choice. Faisal knows more about the details.
Yeah, I think that was a great answer, Floyd. I'll just point out that physical machines always give you better, or more specifically, bare metal gives you better performance always. So if you're looking for maximum performance, bare metal is the best option. But we have a lot of customers that run on VMware, a lot of customers that run on AWS. So it's just really a matter of what works best for you, your environment, your application.
Here's a question that I don't know much about. Anything on Elastic? So we're getting asked also can you use load balancing to balance data for Elasticsearch nodes? I don't.
And yeah, unfortunately, I don't have a good answer for that. And I'm not entirely sure how, if Elasticsearch just uses standard HTTP, then it could. If it uses TCP, it's possible. But I haven't tested that, and I don't have an answer, unfortunately.
Here's a question: are the location block URLs exact match, or do they match all the subpaths? And Faisal knows the answer to that, but I think it's a good one.
Thanks, Floyd. And the location blocks with NGINX are powerful for a reason, and they're highly configurable. So you can configure it to location equals and then a URI, then it's an exact match. If you just do location and then a URI, it's the URL and everything underneath it. You can also do a regex as well, so you can go location tilde and then have a regex and match the regex. So it's basically the answer is all of the above.
I think that answer also applies to this question. Can we proxy pass to a virtual folder like proxy_pass and URL http:// my_upstream/my_folder? And I think that's, yeah, yes, and as Faisal said basically in the previous question. Here's an interesting question. I never thought of it myself. How is health check tied to persistence? And then as a parenthetical extension of the question, hard down versus finishing existing and markdown, et cetera. Let me pass that over to Faisal.
Yeah, great question. And my initial thought there is that if something fails, the health check, then you can't really gracefully shut it down, right? Because it's failed. So my thing is, I think it's a hard down, but I don't know off the top of my head the answer to that. But my guess is that if it's failed, it's failed, and NGINX just stops sending traffic to it.
Something that we've done some work on is things like strategies around the circuit breaker pattern. So if you look up the circuit breaker pattern on our website, you'll find quite a few resources there. It becomes more important in a microservices environment because when your monolith fails, it's, oh heck, all hands on deck, we got to fix this. But microservices are assumed to be prone to failure at any time, and the system is supposed to be in action more or less self-healing. So there's some really interesting answers to that question, and the circuit breaker pattern is not something that NGINX invented at all, but it's something that we like to include in our architectural recommendations, and people are enthusiastically embracing it and taking it, very far. Because once you get your circuit breaker pattern working correctly and can replicate it, the stronger you make it, the stronger your app and every app that you do becomes based on that knowledge and the particular needs of that app. So that's something that we're always working on, and I think everyone in app development and all of us suppliers are always working on because it's so important. And it's interesting as well because you're pioneering in architecture. Another question: what is the default load balancing strategy for NGINX? So I assume that you mean there are several approaches, such as round robin, that are supported by NGINX open source, and a couple of additional ones that are supported only by NGINX Plus. And that's part of the reason that NGINX Plus tends to get used in larger and busier environments. But let me ask Faisal to actually name each of the strategies, which goes for which version of NGINX web server and reverse proxy, and who uses what when.
Thanks, Floyd. So the default load balancing strategy, if you don't specify it, is round robin. And we also have a least connections load balancing algorithm. And I guess there's something I have to go through in the presentation, but you just specify least_con within the upstream configuration. And there's also a least time way to do it, and that's exclusive to NGINX Plus. So that's the third option. That factors in response time. For example, if your servers, or your load balancing servers that aren't all in the same data center, there's a network in between them, then you can use the least time to favor the servers that have have a quicker response time. And actually, I just wanted to follow back up on the previous question, because I was thinking about that a little bit more. The question was, how is health check tied to persistence? And I think the answer there is that it's not a hard down. You can use NGINX health checks to actually gracefully take servers out of production. So if you mark it as down, then NGINX will stop sending traffic to it, and so there'll be no new traffic going through it, and then you can monitor that server when all the existing connections have died down. You can take it out of rotation. So it's actually a graceful shutdown. NGINX doesn't actually pull the plug and terminate connections or anything like that.
I want to note that it's 10:58, and I think that we're willing to go over a few minutes answering questions. So we're going to try to keep going through the questions list. If you have a hard stop at the top of the hour, I entirely sympathize. That's how I usually schedule myself. So we'll be making the entire webinar available. So if you have to go off to another meeting or any other commitment, please do, and you'll be able to get the rest of the Q&A from what we distribute. Also, if you have a question before that, send it in, because we'll try and answer as many questions as we can in probably 5 or 6 minutes. We'll go over. All right, so thanks for that, and we'll go on to further questions now. Can we integrate active health checks with Graffiti or Splunk dashboard for generating reports? I can say that in general, there are a number of most of the major monitoring providers have integrations with both NGINX open source and with the additional information that's available from NGINX Plus, and NGINX Plus is great for that. I'm also going to do an additional plug, though, for NGINX Plus before we get into the detail of the question, which is simply that a lot of people really like a couple of softer features of NGINX Plus, which is, first of all, support. We have award-winning support, and if you're in a busy server environment, having support available can be simply vital for all of the software and services that you use to make that happen, certainly not least for NGINX. Also, more generally, and it's kind of a soft feature, but our larger customers in particular like having a relationship with the company through support and through getting, what we think is our very best foot forward to be involved with giving us feedback about what's working, what's not, what's coming out in the next version, and what's not. It takes time to add features to something that is as widely used and has such demands placed on it as NGINX open source and NGINX Plus. But our customers have been pretty happy with our progress over the time that I've been here and the many years before. So now let me get into the details. Again, that was, can we integrate active health check with Graffiti Splunk dashboard for generating reports?
Thanks, Floyd. And so can it be integrated? The answer is yes, it can be integrated, because we do provide the information on whether a server has passed the health check through JSON with NGINX Plus, and you can find this information on our blog. So it can be integrated. Whether or not the Splunk dashboard, for example, actually does integrate, I don't know, because I've never used Splunk. So I don't know if it does, but you definitely can. You can get to that information through JSON and plug it into whatever you want. So that information is absolutely available to you.
A quick specific question. Could you do, quote, server _name space $host, end quote? I'll pass that to Faisal.
Yeah, I'm not sure if you can, if that's accepted syntax, but it just doesn't make sense to me. If you don't put server name, if you don't even put a server name there, then it'll just basically do star. It'll take all server names, right? So by doing server name money host, you're saying take the original host header specified from the client. So that basically, I think you can just not have the server name directive and get the same output.
Why would you terminate SSL and then use SSL to the upstreams? That's a good question, and I'm not sure that you would. Let me ask Faisal.
Yeah, great question. That does come up all the time. So I have a couple of different thoughts there. One is you don't have to terminate SSL. You can use NGINX, and it's part of the TCP load balancing. So you can use TCP load balancing to have NGINX just load balance SSL connections without decrypting it. And what you do get by decrypting it is you can do things like persistence, for example, right? You can't do session persistence, at least cookie-based session persistence on an SSL connection, right? You can't, NGINX then can't do access logs so easily if the SSL connection is not terminated because the host header and everything is hidden. So you don't get any sort of visibility or control. And if you do terminate it, and even if you do re-encrypt it, at least you get the visibility and some control functionality. So that's why you would do that.
I'll repeat an old joke. Steve Martin said that he didn't like the movie Crouching Tiger, Hidden Dragon because there were no tigers or no dragons. But finally he realized that the tigers were crouching and the dragons were hidden. So, sorry about that. What if a cookie is disabled on the browser side? Sorry. How does it work if the cookie is disabled on the browser side? Is there any alternative if the user disables their cookies? And I'll pass that over to Faisal.
So if the user's disabled cookies, you can't use the cookie-based session persistence. You have to fall back on the hash-based session persistence.
The HTTP2 support is only in NGINX Plus. I can actually comprehensively answer that one myself. HTTP2 support is in both versions of NGINX and has been for since shortly after HTTP2 was made available. We've really played a leadership role in both HTTP2 and the SPDY, the precursor protocol to HTTP2. We were leaders in making it available to people, and our users were leaders in implementing it. So we're proud of that. We like to be on that kind of cutting edge where you're not doing anything risky. You're just getting the latest and greatest out into your supporting your app and benefiting your users. So yeah, we've never had any differentiation in HTTP2 related features between the two versions. I'll just go on to the next question. Can NGINX load balance with the sticky session feature based on a certain property within a JSON payload like HTTP post data? I'll ask Faisal to go into the details, but I would guess the answer is yes.
So that's a tough question. I'm not sure I fully understand it. So I think this kind of gets into what we call the sticky learn. So NGINX can load balance based on stuff in the payload, but it has to be a cookie. So it can load balance based on a cookie that you set, for example, JSession ID. But I don't believe we can do sticky sessions based on just arbitrary data in the payload, but I'm not 100% sure that. I'm pretty sure that it has to be some sort of cookie. Makes sense if it's a cookie.
Yeah, Faisal just said it only makes sense to him if it's a cookie. In the MySQL example, it will do the switch C to the backup server, or is a manual change needed? Oh, right. Will it do the switch to the backup server, or is a manual change needed?
That's a good question. If you specify the backup parameter, then it will automatically switch to it as a backup. If you specify down, and I use both in the example, then down is a manual one, but the backup will be an automatic switch.
I think we should just do 3 more questions and then we'll wrap up. We may do another session in the future just to keep going on questions because these are such good ones. How do you maintain session persistence while clustering? That sounds like a great question. I'll pass that to Faisal.
Good question. And then the reason I picked the sticky cookie is because that does work across persistent or across clusters because there's no actual state on NGINX. The state is stored in the cookie. So you would use a cookie-based session persistence, and that's how you maintain session persistence across clustering. You could also use the hash. I think the same, if you put the same parameters into the hash, the output's going to be the same. So you can also, use the hash because there's no actual state stored on NGINX.
2 more questions, both really strong ones. Is there any way to add security on top of the load balancing? I'll just say in a general way that yes, and that's one of the things that's the advantage of using a reverse proxy, whether you're doing load balancing on it or not, is that you can put security on the reverse proxy server, optimize the heck out of that without interfering with your app servers or their operation. So I don't think that there's any general barrier. There are 3 providers on the NGINX website who do specialized security modules as well. There's the NGINX Plus with mod security, WAF, and then a couple specialized additional modules. And let me turn that over to Faisal for more depth.
Thanks, Floyd. And I'll just add on top of that you can do, there's a lot of stuff I didn't discuss in this webinar. So you can do HTTP basic authentication with NGINX, and that's the standard basic auth that you see, the pop-up form thing. You can also have NGINX initiate a sub-request. If you have LDAP, for example, you can have NGINX initiate a sub-request to the LDAP server, and we have some kind of proof of concept stuff on our website. Or you can just have it in general, initiate a sub-request to your authentication server, and the authentication server gives a thumbs up or thumbs down. That's another way to do authentication with NGINX. You can also have NGINX validate JOT tokens. This is something that's specific to NGINX Plus. You can have NGINX Plus, validate a JOT token, and then either let the user in or not allow the users through. There's also rate limiting, and we had a webinar on that I think just a month ago on rate limiting. So that's another thing to watch and look at to to kind of mitigate DDoS attacks. And then the stuff Lloyd said that you can run some WAFs with NGINX. So you can run mod security, and you can run mod security both with NGINX and NGINX Plus. With NGINX, you have to compile it yourself from the source. And we have a blog on how to do that. And NGINX Plus, we build it for you. And we also have the wall on WAF and a number of other different modules that you can plug into NGINX Plus.
Yes, this is a subject that each of us and the company as a whole is pretty passionate about. One of the things that we really like is that we work very hard to try and help you guys create implementations where you can have connection persistence while using SSL to really minimize the performance penalty. So just to go off into a specific answer for a minute, the Fabric model that we recommend for microservices use actually keeps connections persistent. We ran some tests, and well fewer than 1% of the messages required a new SSL connection. The vast majority of them were able to use an existing one, saving you the setup tax on those messages and keeping performance at very close to non-SSL levels while having that protection throughout the entire stack for every message between any two services. And there's much more about that on our website, and we could go on. Last question, can you speak a little bit about monitoring during a performance test? And in general, one of the advantages of Plus I'll mention is that there's a lot more information provided for reporting and a kind of a dashboard in Plus. So I'll ask Faisal to speak to how that works during a performance test.
Yeah, thanks, Floyd. NGINX itself, the open source, has some stats. It's called a stub status module. And you can look at that, and that's part of the open source, and it has some high-level stats, total number of active connections. It's aggregated to the entire server, but that's available. NGINX Plus has a lot more stats, so you can go to demo.nginx.com to see all the stats we have available there. When I do performance testing, I usually just rely on the testing tool to provide the numbers as to how well the test is performed. So if you use a tool like WRK, which is what I typically use, it has an output of how many requests went through, what the throughput was. So that's what I typically look at during performance tests more so than stuff on NGINX itself.
I'll also mention NGINX Amplify, which is available now as a free beta on our website as a tool that you can use for additional monitoring as well as checking your configuration files. Well, thank you. Our attendance for this session was fantastic. We had a lot of people registered, a very large number of people online during the session, and we'll be distributing the recording of this to all of you within a day or so. Thank you also for the questions. We learn a lot about what's important to people using NGINX and NGINX Plus, and I will finally finish by mentioning the NGINX Conference 2017, which is September 6th through 8th in Portland. September 6th through 8th is a Monday through the Friday. Wednesday and Thursday is the actual conference, and the Friday is a training day. I think we still have openings for NGINX core training on the Friday. If you sign up now, you get 50% off and use the code webinar. We're going to have our usual array of, we think, fascinating speakers, because some of them are us, and we're also going to lighten it up a little bit this year. Jimmy Yang from the HBO show Silicon Valley is going to be attending and helping close up the conference part of the 3 days on the Thursday night. So again, NGINX, just look up nginx.conf and use code webinar to get 50% off. And thank you all very much.
Thank you again for joining us. Our previous webinars are available on demand on our website on nginx.com in the resource section, so be sure to check those out. If you're looking for more hands-on experience with NGINX Plus, we also have a 30-day free trial available by request on our website. Thank you again for joining us, and have a great day.